Hi friends, welcome to my channel. Let's have a look at a newly appeared problem. Problem 2588. Count the number of beautiful subarrays. In this video, we're going to explain a solution based on dictionary and check method. So here, dictionary is a Python dictionary abstract data type. You can understand it as a hash table or hash map. So first I'm going to read through the problem statement to digest the requirement, and then we explain the idea and the plan, and finally we share the code, and in between we explain the process line by line. First, let's look at the problem statement. So we are given a zero-indexed integer array called nums. So in one operation, so we can do the following. So we can choose two different indices with the inbound, right? So we choose the non-negative integer key such that the case bit in the binary representation of nums I and nums j is 1. So in other words, they are the same. Then we're going to subtract 2 to the power k from the two numbers. So next paragraph introduces the beautiful subarray. So a subarray is beautiful if it's possible to make all of its elements equal to 0 after applying the above operation any number of times. So we are required to return the counting or the number of beautiful subarrays in the array nums. So the last paragraph basically tells us to distinguish between subarray and subsequence. A subarray is a contiguous piece. Here it specifies that it should be non-empty. So with that said, so let's look at the example. So here, so two examples, like in example 2, so the output is 0. So because there are, so you can check all the length 1, length 2, and length 3 subarrays. Then you can check the possibilities is 0. So this is the actually very brute force. But here, because the length is 3, we can't do the check. So in example 1, so there are 5 elements. So the output is 2. In other words, the possible beautiful subarrays within the nums is 2. So you can digest the return by the explanation in which the problem specifies the beautiful subarrays. So before we do the analysis, let's also look at the constraints. First, the length is bounded above by 10 to the power 5. So this actually is a decent large number. So we need to be careful when we solve this problem. We cannot use pure brute force. Secondly, so the elements in the list is bounded below by 0, but it can be 0, and bounded above by 10 to the power 6. So with that said, actually we are ready to do the analysis. So for this problem, actually there are some very suggestive hints. Like it says that subarray is beautiful if its XOR, or in other words, exclusive OR is equal to 0. So this exclusive result is 0, meaning that there are corresponding same bits in the corresponding bit positions. Like you have 0, 0 in that bit, you don't need to subtract. That bits, 2 bits are already 0. And if you have in the same bits position, you have 2 1s, then subtracting 2 to the power to that index corresponding to set it to be 0, right? So if you have 2 1s there, then you consider the exclusive OR result. Then you will unset that bit. In other words, to make the corresponding bit to be 0. Therefore, this hint actually is very suggestive. It almost gives us the solution, I would say. So with that said, let's look at the treatment. So here I'm going to use the dictionary and check method, or just a technique. So this is actually very routine. So if you check in my channel, so you can search dict and check. There are quite a number of problems of this kind, so you can practice this technique. Now let's come back to the problem. So here the idea is very straightforward. So what we are going to do is that for each index g, we want to find the number of beautiful subarrays ending at that index. Then the return for this problem is just the sum of these numbers at each index. So if we want to do the problem like this, then the question comes to be how to do the counting. So this is also very routine. So let's assume that the exclusive OR result, so let's consider the elements from the index 0 and ending at the index G. So the exclusive OR result is defined, let's assume the result is F. In other words, if we consider the exclusive OR from num 0 up to I and up to G, then this is F. So if there are some index, let's say I, so if we compute exclusive OR from beginning to I, then its exclusive OR result is also F. And then if we consider the exclusive OR of these two parts, this part and this part, because exclusive OR has a property, if the same number you do exclusive OR, this plays the role of annihilation, right? So F exclusive OR with F, it will be 0. But if you look at this part and this part, so you exclusive all of them, then this 2 0, num 0, 2 nums I, so this parts are going to be cancelled. So what left us is nums I plus 1 up to nums G. So in other words, we have this one. So the exclusive OR result starting from num index I plus 1 up to G, so it's 0. In other words, the index, the subarray starting from index I plus 1 and ending at G is a beautiful subarray. So therefore, to count the number of beautiful subarrays ending at G, so we just need to use a dictionary to retrieve the frequency of this F, assuming that the exclusive OR result up to G is F. So we just need to track the frequency of this F appeared before G, right? So this is a walkthrough for example 1. So in other words, ending at index 3, there is a beautiful subarray, and ending at index 4, there's another one, right? Ending at index 3, the corresponding one is this one, 3, 1, 2, right? And another one ending at 4, and you choose all of them, right? But in this walkthrough, I didn't specify the specific array. So, but if you in the dictionary you store the indices, you will be able to specify the subarrays. So with that said, let's do the coding. For this coding, actually, we have practiced quite such examples. It will be very straightforward. First, I'm going to make a dictionary. So I'm going to start with 0, because if nothing has checked, so we will regard the prefix or exclusive OR result of the prefix will be 0, right? And then I'm going to initialize a result. This is the integer, so do the counting, and we are going to return its final state. And then we're going to define a variable. Let's call it a product of XOR. It's just the XOR result of all the elements up to now. So let's say it's at the very beginning it's going to be 0. And then because in this problem we are not required to retrieve all the specified subarrays, so we don't need to pay attention to the indices. So we just do a direct iteration. So for y in nums. So if we want to specify or store the indices rather in this dictionary, so we can do for iy in enumerate nums, right? So with that said, and then what up to now, so what we are going to update this one. This is you can regard it as a running variable. So we do exclusive OR with the current element we're going to look at. Then this is the product exclusive OR up to the y. Then we want to check how many times this y appeared before, right? So that's if there are non-zero frequencies, it means that we have some beautiful arrays with different starting indices but ending at this corresponding index. Then we're going to increment the result. So let's first get a frequency. So what we're going to do is to get prod OR. So this method basically checks the value for this key in the dictionary. If this key does not appear in the dictionary, so we're going to set a default value, and so here should be 0, right? And then we're going to increment this result by frequency, and then we are going to go to the next round. So we need to update the key, right? So we're going to do prod XOR. So originally it appears before this corresponding index this number of times. Now it appears again, right? So we're going to increment by 1, and then this is the whole for loop. So we need to pay attention to the last element. For the last element, so we after we do this check here, so we don't need to do this update because we don't check anymore. But doing this, there's no harm. So after that, we can return the result. So this short piece of code actually forms a solution format to this problem. So before we do any comments, let's do a check. Yeah, it passes the first example. So I want here to examine another example because in the constraint it's allowed the element to be 0. So I want to check this one. So if you have a number of zeros, right? So for this problem, because any subarray will be a beautiful subarray. So the total number of subarrays, we have 3 length 1 and 2 length 2, this one and this one, and 1 length 3. So the output should be 1 plus 2 plus 3, that is 6. Let's check. Yeah, it's 6. So with that said, I guess we can check for all the cases. Yeah, it passes all the cases. So with that said, I would say some brief comment about this problem. So first, the technique here where we used as the dictionary and check. Sometimes we do not need to use dictionary, so we can use set and check. So actually this kind of method can be regarded as deriving from the very first problem in Leetcode, that is the to-sum problem. So you can check out my channel and search dictionary and check, or look at the corresponding video for a very easy problem, that is the to-sum problem, to digest and retrieve all such practices. So this is number 1. Number 2, so in this problem I would say the hint is very suggestive. Basically the hint number 1 is almost giving us the full solution if you have practiced decently in Leetcode. So with that said, I guess that's about it for this specific problem. So before we end this video, so let me say 2 things. First, the time complexity. So I don't want to to do more detail because it's just the OM. N is the length of the nums. So basically we have this while loop, and then we do some key retrieval and update, right? That's why we have a constant up to n. This is one thing. Another thing is that, so let's do an extension. So can you find specifically all the subarrays, all the beautiful subarrays, right? Beautiful subarrays. So here actually you can modify the dictionary, right? So to have the indices, then the length will be the time it appears, and the corresponding array itself will record the corresponding beginning index. So with that said, I guess that's it for this video. Thank you.